like the different difficulties. I can't remember if I even ended up going with like the expert level.
Thank you, man.
This is a little bit weird.
You didn't have anything about, I don't remember, there's nothing that saying that you had to do different difficulty levels, is there? Or, maybe you mentioned, because I haven't gotten the computer AI, maybe the computer AI was gonna be smarter or dumber, I don't know.
Yeah, he had like a easy, medium, hard thing. So I think I ended up just skipping the hard one because I couldn't figure out the algorithm for it. But I still ended up going whatever's there.
Yeah, my main goal was just getting the program as a function. So,
That's the hardest part of the program. That's the hardest part of the program.
Advice on my part is he suggested to me to slow. From what I've heard, did you make your array global or just global?
Question with that. Remember if the computer yeah, easy and expert. I skipped the expert. Because I couldn't figure it out. He's still doing it.
I thought that's right. That's like good because I didn't have half the stuff.
You'll be fine.
I'm not worried about it.
Yeah, but just like, yeah.
If you imagine I gave him a evil I like imports and I said the whole route. I don't know, I couldn't think of what it was. He was like, buy or anything, I just had to leave the room.
I'd be really interested in seeing if you do end up getting the expert or the intermediate algorithm down. I'd love to see what you can come up with that. Because I could. I probably did. But it was slow. When I sent it to you, I just briefly skimmed through it. So I could make sure that I had it.
Yeah, and I like him.
Oh, yeah, see, why don't you just get it on 7.5?
Well, I mean, you can do the same one.
Yeah, I was surprised when I saw that it was all in file too. I was
So,
like,
because like withdrawal, here's my from the last one, I couldn't major. It's not like, it's not my major anymore. Well, I started taking it in the summer, then I was like,
Mine's pretty
well, it's all
condensed,
online, I don't
but-
like that. So I'll just take it in the fall. And I started taking it all, and I was like, oh no, it's still the same thing. It's still all by yourself. Yeah. I'm like, I guess I'm gonna be in this major now.
we just like, that's right, the instructions. Yeah.
You got 50
I know, I mean, it's still over 100%. To get extra credit. Probably you like tax credit. She said, she's like, oh, you forgot to add in that get month salary and 7 month salary. I was like, just keep getting extra credit about the
this one I had, I just believe it.
Okay guys, so what we're going to do today is we're going to finish up these last few problems involving mathematical induction, and then we'll spend some time talking about what's going to be on the examination for Wednesday. If you guys have some specific questions for me, I'll be happy to answer those for you. Okay? As regards to the homework, if you want your homework back graded before the examination, just shoot me an email. I'll scan it into you graded, so that way if you want to study from it, I'll also post the solutions so that way you guys have that as well. Okay? So, any questions about anything, guys? Okay. So, the last ones we looked at with induction, we looked at the series type. So we proved some formulas with regards to some series. But we could also utilize induction to make some things that we used to be able to do that were kind of complex a little bit easier. And I know what you guys are thinking. How is induction any more easy than some of the stuff that we've been doing? Okay? So let's take a look at something like this, to where if we have any integer that's bigger than 0, n cubed minus 7n plus 3 is going to be divisible by 3. Right? Now we could do this problem without mathematical induction, okay? But unfortunately it would be extremely tedious. Okay? Does anybody think they might know how to try to tackle this without induction?
Divide this by 3?
We did one more time?
Divide this by 3?
Not that it,
Oh, so n cube, that has a factor of 3a, right? Then plug this in?
well, let's suppose we don't have induction, like some
Okay.
other method. So, couldn't we use division into cases?
Uh-huh.
Couldn't we just say evens and odds and then prove it that way? So we basically have to do the proof twice. With induction, it actually helps it so we only have to do it once. Okay, so when I say it, I mean the tough stuff. Okay, so let's go ahead and try to prove this thing by using our induction stuff. Okay, so here's our proof. The first step that we have to do is the basis step, right guys? And the basis step is the easy stuff. All we're going to do is plug in, let's say 0 for this. Okay, so let's let n equal 0. Okay. We get 0 cubed minus 7 times 0 plus 3, which is equal to 3, which is equal to 3 times 1, right guys? And because it contains a factor of 3, it's divisible by 3. Everybody in here knows this, right? We could have used 1, we could have used 2, we could have used 55 if we wanted to, but we always want to use the most simplistic one, okay? So, thus, the basis holds for small values of n. Now, the second thing we do is we do the inductive step. Okay, that's a pretty easy step. Remember what we do is we say we assume the result holds for all n equals k. Okay, so we assume the result holds for all n equals k, where k is an integer. Thus, k cubed minus 7k plus 3 is divisible by 3. Okay. And again, that's our inductive hypothesis. We're assuming that the result holds. And because it's divisible by 3, okay, what else could we say about k cubed minus 7k plus 3? It could be equal to something. What would it be equal to?
3a?
3a, where a is an integer. Good. By the very definition of divisibility, k cubed minus 7k plus 3 is equal to 3a. Okay, so we could say, and by definition of everybody's favorite word, divisibility, k cubed minus 7k plus 3 is equal to 3a, where a is an integer. Okay. So let's say on Wednesday you guys have this problem, we do at least that much. Okay, I'm inclined to give you at least 4 points for that stuff. Okay, out of 15. Okay, now you guys want all 15 points, obviously. Okay. So basis inductive. Okay. What's the next thing that we have to do with any sort of induction proof?
n equals to k plus 1.
We substitute, we have to prove for the k plus 1th case. Okay, so now we're going to let n equal k plus 1. we're just gonna substitute k plus 1 back in for n, okay? Just like we've done many, many times. So, by substitution, n cubed minus 7n plus 3 is going to be equal to k plus 1 cubed minus 7 quantity k plus 1 plus 3. So, let me give you guys a minute to copy all that down, make sure that's all okay. Anything sneaky I've done there, guys, or any questions thus far that I've done? Okay. All right. Now, of course, we have to prove this is going to be true for the k plus 1th case, okay? And usually what we do is we immediately use induction if we can. Unfortunately, in this case, we can't immediately use induction, okay? We'd like to, but we're not. So does anyone maybe have a suggestion as to perhaps what to do at this point with this? Yeah, unfortunately, we don't want to FOIL this out or distribute, but in this case, we're going to have to, okay? So sorry about that, but this is just one of those types of problems where we have to FOIL it out. If it was a square, everybody would be okay with that, but because it's a cube, then we're not so okay with this, okay? So maybe somebody remembers.
Let's do the Pascal, that's easier.
You can use the Pascal's triangle. Like, for those of you guys that don't remember Pascal's triangle, or don't know, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Basically, all you do is you just add adjacent numbers to get the number right below it, okay? Or if you wanted to expand it, you could just do this, k plus 1 times k plus 1 times k plus 1, okay? And you can just FOIL it out 3 times that way. There's a number of ways that you could expand k plus 1 cubed. But guys, these numbers right here, what Art was talking about, the Pascal's triangle, these are just the coefficients of the powers of k, okay? So if I wanted to expand this animal, okay, using Pascal's triangle, or you can just FOIL it out like this, okay, whichever way works for you, it doesn't matter, okay? This is going to become k cubed plus 3k squared plus 3k plus 1, okay? If you don't believe me, go home and just FOIL that out. So basically, guys, that's just a big ol' exercise in FOIL, collect like terms. I'll spare you guys the 4 or 5 minutes it would take to FOIL it out and do that. Okay. I'm going to distribute the negative 7, so I get minus 7k minus 7 plus 3. Okay. And that's just by FOILing it out or multiplication. Or if you really don't believe me, just use your TI-89 and FOIL it out. Because no, a TI-89 wouldn't lie to you. Okay. All right. Now, usually what we've done, in fact, 99.999% of the time in mathematics, what would be the next step that you guys would do with this? Combine like terms. And if you combine like terms, you are wrong. Okay? Because every fiber of your being says, well, I've got a k and a k and another k. I want to just make that a negative k. Why don't we want to go through and combine like terms in this single solitary example?
Because you want to bring that 3/8 like over there from that second.
Didn't we say that k cubed minus 7k plus 3 equals 3a? If we combine like terms, we're never going to see this, are we, guys? So, or we'd have to go back through and we'd have to break it apart again. Don't we have, right here, we have our k cubed. That's a horrible triangle. Just pretend it's a triangle and not like a dodecahedron. And then we also have a minus 7k. I'll try to make this one better. There we go. And then we also have a plus 3. So guys, isn't it true that those 3 terms, or at least I tried to do, here, let me try to make this better. I know it's not going to work. It's like when you get in an argument with your boyfriend or girlfriend, you try to make it better, and it's just worse and worse and worse, so then you just shut up. But those 3 terms, those are equal to 3a, aren't they, guys?
Mm-hmm.
Okay? By induction. So we can say that this is going to be equal now to, instead of k cubed minus 7k plus 3, that's going to be equal to 3a plus 3k squared plus 3k. And then, don't we have like a 1 and a negative 7 there? Couldn't we just combine this 1 and negative 7 and get a minus 6 okay, just to save ourselves a step. I wouldn't want to rewrite that entire line, just so that way we can go through and just take 1 minus 7, okay? That's by induction, and then there's a computation step in there. Not that anyone cares, but. So that's induction slash computation. Okay, so, everyone's okay with what we did there, and everybody understands why we didn't combine like terms, okay? A little bit sneaky, okay? If you were to combine like terms, you'd have to break them apart again to be able to get to where we wanted to be with this, okay? So it's just easy not to combine. Okay, I think we're almost done with this, right guys? Because what do we want to show that this algebraic statement contains?
3a.
Factor of 3, right guys? So how do we show it's a factor of 3?
Take 3 common.
Factor out of 3, right? Don't they all have a factor of 3? Let's pull a 3 out of there. If we factor a 3, we're left with a plus k squared plus k minus 6. I'm sorry, you're right, duh.
It's simple math.
I know. That was multiplication. Which one am I bad at? Apparently both, right? And guys, what do we know about all that stuff that's in parentheses?
It's an integer.
Just an integer, we can call it b, we can call it e, we can call it whatever we want.
As long as it exists within.
Correct. Yeah, we want to make sure it is an integer. And that's just our closure stuff. Alright, we're done, right guys?
Right.
I want you to notice the only difficult algebra in this step was probably foiling out that k plus 1 cubed. Okay,